Hello everyone, sorry for the delays and the issues there. So my name is Yves Desharnais. I'm going to be presenting to you on a project I did and the tools and approach I've developed out of it. So just a bit of disclaimers. This represents my work, it's nobody else's. Your mileage may vary. I had to do a lot of debugging to get some of these tools working. Hopefully you won't have to, but I can't guarantee I'm going to fix your code. If there's issues with that, I'm going to try, but I'm a Ruby newbie and all this code is Ruby. I've developed in a lot of languages, but there's still some quirks there that I'm not used to. So just a bit about myself. I'm an IT information security generalist. I have over 16 years of experience. I started information security way back in 2001. I did come up from a background in application development, started low level going up the stack, and doing a lot of Unix and Linux system administration, which probably geared some of the tools that I use. I'm an author of books on PCI DSS, and I try to explain this. Amongst other things, I have a Creative Commons available methodology on that explains how scoping works for PCI DSS. It's one of the reasons that brought me to this project. So this talk really is about the story of necessity is the mother of all inventions, and that's why I had to create some of these tools. I could have called this talk Extreme PCI DSS Co-Production, or how we remediate a medium-sized flat network in about 19 weeks, which we did. But the approach and what I've developed here, I think, goes way above and beyond this. And it really started with a LinkedIn message that I got that was cryptic, not too much information. I wrote down back then 4 things when I went to the interview. They wanted somebody that knew PCI DSS, that could do penetration testing, that was a CISSP, and bilingual. I'm in Montreal, so bilingual is one of the things you get there. So I go to the interview, present, get asked a question for about 10 minutes, and then about an hour, 20-minute worth of explanation of the situation of the company. And this is what I got. So they're a company doing that is on a second-year extension for compliance with PCI DSS, but they've been given a deadline that's under 5 months away to remediate everything and get everything. They're an acquired company, so that's the company network we're trying to fix, not the acquirer, but the acquired company. But it's a flat network. It's mostly VMs, about 800 on server side, with other machines as well. There's no patching, no hardening done ever. There's few documentations. There's a bit that have been generated recently due to a migration to the new network and the integration of the companies. But what they wanted to do is to remediate in the new network, but they realized that they won't have time to get there, so they have to fix it. They have, for those that are in the PCI sphere, they're using card number tokenization, which means that they should have less card numbers in their system, which makes it a bit easier. And they had a very competent IT staff. And really, the hour-long interview lasted an hour and a half, which tells you how bad things were. But my first thoughts when I got there is, how can we remediate these things? And talk to anybody that's done PCI, and they'll tell you the first thing you're talking about is co-production. But in this case, we only have under 5 months to do, and a lot of servers and a lot of work to do. So there's also the ongoing projects in the migration that still are ongoing. So really, this is called for massive, but really massive co-production to be able to even have a chance of really meeting those deadlines. So we threw everything across the board, but that required, in order to reduce scope, to understand who's talking to whom, so we can say, okay, you're out of scope, you're not. I can take you out of scope by doing these, either process changes, IT changes, migrating, and then you need to identify things like, oh, well, an unsupported OS, or Windows 2003, that can't be in scope, what do we do with it? So, but understanding this requires understanding who's talking to whom, generally at a network level, which is the first area we look at. So my first thought was, well, okay, well, we'll create a span port on the router, the switches, whatever, and we'll capture traffic, we'll analyze it, but that's time consuming. And by happenstance, in the meantime, between my interview and the start of the contract, I had to get together with friends, mostly networking folks, and that's where to everybody else, talk to everybody else. I didn't know there was such a thing called Netflow back then. And they mentioned it. I told them about my problem was going to try to do, and say, well, why don't you look at Netflow? It can provide a lot of the information that you need. So I started looking at that. So I get in, start working, late March, and after 24 hours, I come up with a plan, really has 6 major steps. So we need to identify scope and reduce it. Then we'll have to fix and do vulnerability management and all the penetration testing work. We'll have to apply all the access controls. We'll have to remediate the systems, all the patching and hardening. That's a lot of work. And then set up logging and monitoring for those tools, because there's nothing there. And then a couple of miscellaneous tasks, policies, procedures, stuff that I didn't take care of, but that was less relevant. But if you look at steps 2 to 5, really these are dependent on what you identify as scope. So that made it all the more relevant. So just a quick question, any one of you have worked with the Netflow protocol in the past? So a few of you. Have you used it as part of your SIM tools, or no, just regular usage? A lot of network folks do know it because they're using it for performance analytics. I'm using it for security purposes, so it's a tad different. So I'll just give you a very quick overview. There's really 3 major versions. Well, you see it goes up to 10, so there are other versions in there, but they're not really in use. Version 5 is the real big, older commercial one that was in older Cisco equipments. It only supports IPv4, and so it has limited, but it is fixed in format, so it's easier to implement, easier for older equipment, so it's got less information. But I still got some of that information as part of my work. Version 9 is actually probably the most common one you're going to get. It's template-based. So template meaning that you get a template sent every once in a while that describes what's going to come in the next packets, and then the packets get sent and match that template. This is really all the new equipment, but some other providers, I think Palo Alto is one of those that supports Netflow v9 directly out of the box. And then there's Netflow v10, also called IPFix, because that's an ITF standard. Got the RC numbers there. It's extremely similar from a protocol perspective. There's very little variations from v9, but provides some of those. But if you're using things like VMware, which we were, VMware will provide you IPFix information instead of Netflow v9. So you need to be able to parse that. There's another protocol which you may hear called Sflow, and I've just mentioned that. Sflow is a sampled flow, so while it's great for network behavioral, for performance reasons, it's not really useful for a security perspective, not for my uses anyways. So I get to, okay, now I want to use Netflow because that's going to be an easier way to do it. How do I go about it? I did a bit of market research, try to figure out what I could get. I didn't have much budget, could get VMs, I had very little time to figure out on the tools. And while I found many tools that did support Netflow, most of them didn't meet my needs. I wanted to be able to get the raw data to do the analysis the way I thought it needed to be done. And I don't think those tools are made for that. So I basically came down to a roll your own solution and identify 2 products, Logstash and fluentd. So both are Ruby-based, both are similar. I consider them basically siblings. They're very similar, and there's actually a lot of porting of code from one to the next. Logstash is a bit better known in the community, so if you've ever heard of the ELK stack, ELK, Logstash is the L in there. The other 2 being Elasticsearch and Kibana, which is an open source search engine, and Kibana is a GUI on top of it. But fluentd is a bit more decentralized. It's written in Ruby C, which means it uses less memory. The other one is written in Ruby J, so runs on the GDK, so will be supported easier on a Windows system, for example, than fluentd. I chose fluentd for multiple reasons. A lot of this stuff probably could be done with Logstash as well. I just haven't done it. But both of them are very similar from a conceptual perspective. So if you're familiar with the Linux command line, you know that it's the original goal of the Unix system was several small little utilities that do one job very well, and then you just pipe the input from one to the next. Those systems are plugin based, so they're using pretty much the same model where you get an input plugin from tailing a file, from receiving a UDP packet and maybe parsing it specifically, to filtering and outputting it to some format. So they're both of them. There's more plugins, I believe, available on fluentd, but some of the nature may feel a bit more hobbyist. So we get to the fun part, because I'm going to be doing a bit of controlled demos. So they're controlled in that I'm using pre-captured traffic. I'm on my own network, so I'm using 2 VMs because you cannot replay traffic from the same VM. But really, I have one VM that's running the code. The other one's just replaying traffic. On a general network, if you set this up, you would really need 1 VM, potentially more if you have more data centers, because this is UDP. But by doing this, for example, by using captured packets, traffic that I captured, Netflow information coming in on the servers, I'm able to take the output of one tool, and if I make changes, replicate and test it out and compare the output to the other tool, which should be the same. So it allows for a lot better testing. So I have a demo slides in here that I've kept just in case we ran into issues that I could talk to, if I couldn't show you. But I'm going to be skipping over those as I go through the demo. And I'll have instruction and code available after this presentation. I'm packaging everything, and I'm going to post it online once that's done, probably over the weekend. So let's go to demos. Is this clear enough for you guys? Can you see well at the back? Yeah. Yeah. So fluentd is written in Ruby. It's installed. I'll have the instruction on there, but it's really a simple script that they give you. It's managed by a company called Treasure Data that set up the system. It's got an agent, and your configuration files are in etc/td agent. TD for Treasure Data agent. It's basically one of the versions of fluentd. You can compile from source, but I chose to not do that. So you'll see I have a bunch of files. I've set it up in folders. Oh, actually, you're seeing the demo. I have to exit this. This is what I'm supposed to be showing you. So you can see that I've got all here demo folders because it made it easier to put the configuration files there. And as you will see the tdagent.com file, I'm just referencing whichever demo I want to run. So that makes it easier to run this demo. The output files are also going to be outputted to separate folders in /var/log/tdagent, which I have over here. So basic configuration for fluentd with just your regular output to the Netflow plugin. So I've installed the Netflow plugin, which is not installed by default, and you can tell it's just the configuration file there. So you have a source input, which is type Netflow, listening on a port, listening on one port on all device. 2055 is one of the regular ports used for Netflow, and then I'm matching that traffic. Either else, it's not going to do anything. It's going to input it, and it's going to be in the system, and outputting it to a file in that folder. So if I do this, and if I do start the agent. Because if I do changes in configuration, obviously I have to restart. It's not running, so just this regular start. And I can do, and just replay my traffic. Now I can show you what happened there in the log file. So it started reading, and you can see it outputted the configuration file, maybe just it rewritten, and then you get a bunch of messages. One, no matching template. Why is that? Because I'm sending a mix in that packet capture of V5 and V9. So V5 doesn't require templates, but V9 does. So that just means that it hasn't received a template just yet. So that is a configuration issue in your devices for Netflow. We had set it up to every minute it would send a template. You can set it up to different frequencies, but generally those plugins will lose the traffic before they get the template. So once you restart the engine, you could lose traffic. So just be mindful and aware of this. So there's nothing more in this, but I can show you the output of the file. And you can see, you get basically a timeline, and then a Netflow event, which is a tag I assigned to it, and then a series of JSONs. If files. So see, if you haven't seen JSON in the past, JavaScript object notation came up from the web application development side of things, makes it easier to create ad hoc objects very easily, which is very helpful when you're trying to build a system that complex. You're not stored to a standard one-liner as you would have your standard input on the command line. But that's pretty hard to do from an end user perspective. To parse that information is a lot more convoluted. So the next thing I did, once you got that, is go to demo 2. And I'm just going to make in demo 2, there's just one tiny little change. If you can see it towards here, there's a format, CSV. So I'm just outputting now, you're changing the format structure. So if I do the same, if I restart, and then I'll be able to, you could actually do a tail here. So it's shutting down, it'll restart. It can take a few seconds there, depending on if it's doing something. And that's the fun part, waiting for this to restart. And even if I send traffic, it'd be lost, right? So I'm just waiting for it to confirm that it's there. And since I'm going to be using the same traffic, you'll see I'm using a little batch file here. Well, I can do that now. If I send the same traffic, you see that it's gotten the same thing, but the difference is in this one, now I've got CSV files. So having CSV allowed me to take that data directly initially, transfer it to PC, process that manually. At one point ended up doing a mix of all command line, cut, grep, pipe, all that beautiful stuff to simplify some of those files, compress them to make them transfer easy. But at least that got me base raw information. But I think we can do better than that. So if we go back to, and we see what's in demo 3. You can see in there, I'm using basically the same thing, but I'm going to be, just to simplify, I'm going to send more information there. So restart it again. I'll show you in the meantime, just to give you an idea. I'm just replaying different packets. That's all my scripts there. You'll have that. I'm looking at trying to give you some PCAPs as well, so you can test that as well at home. But if you do the replay, you just have to do a lot of TCP rewrite between the two VMs that I'm running here. So this is started, so I can do demo 3. If I do a tail, you can see, oh, unsupported Netflow version, because the default plugin doesn't support it. Actually, the default plugin seems to have been imported from Logstash code, which I couldn't understand. There's a bug in it. I managed to fix one, but there's still some issues. You'll also run into unsupported fields. What does that mean? By default, there are fields that are defined in a template in a file format, but if you look at those numbers, they tend to be, some are lower up, but above 32,000, and these are generally vendor-assigned numbers. So if you deal with a new device, you're going to get new numbers. Generally, you'll get that information from that provider, and you can, if I show you in the plugin, Netflow version, it's a YAML, it's yet another markup language file. That's a format I didn't update it. And then basically you can add your file format, so if you want to use those numbers directly in there. So that's fairly easy to do. That's what I ended up doing for the IPFix stuff, which is the next step. Since I didn't have V10 version, well, I say that I can have that. So I'm going to get that restarted. You see this? Now it's matching traffic. So at least this is the plugin I'm going to be releasing. I wanted to do a complete rewrite, but there's dependency issues with fluentd and versions of Ruby that didn't allow me to go to, so I ended up going back, refactoring the code, trying to simplify, clean it. So since V9 and V10 are pretty much the same, I've just made little tweaks here and there. I believe the code is more readable. If there's Ruby experts or Ruby people who know better, I'm more than happy to get help. But if you look at the end results now in demo 4, I've outputted to both files, to both JSON, which is going to be your standard JSON file that you've seen, which you can see all the information's in there, right? The IP addresses, the ports, all that stuff. Problem is if, for this version, I go to CSV versions, what's happening? What happened to my data? It's not there. The problem with that data, and obviously that it gets compressed, so it's in there, but it's using different names, and actually it's providing me right now, for example, for IP address, source IPv4 address, destination IPv4 address, and if it be v6, which it will also provide me, it'd be that name. So those names, the variable names from the protocol change. So that meant that I couldn't just use the standard CSV, so I had to get creative to be able to get all that information. So I'll actually restart this in the background so I can show you just a configuration file. So I'm using my plugin, which is the Netflow IPFix input plugin, but I'm doing a couple of other things. I'm using other plugins. The copy output plugin basically allows you to fork things in different directions, makes copy of everything, and send it to different stores. I'm using a relabel, which adds a label to it, so basically creating some sort of a workflow with this. So this is great. So because I get all the information everywhere and I want to treat every bit of information differently, I'm taking all of the V5 information, parsing it, assigning it to variable names here with a record transformer. These are all standard out-of-the-box plugins that came to this. I added one, which is a lookup CSV, that I use to transform the protocol number from one, which is ICMP, 6, which is TCP, 17, which is UDP, and all of the others, from the standard definition to a protocol name that makes sense to an end user reading it. So I'm doing that, and then outputting files to JSON, CSV for V5, and you'll see the same thing going on for V9 and V10. So if I run my demo 5 here, now that it's running, and I show you, it's going to start outputting different files of these things. And if I take a look at So if I do the V10, which is the one we had issue, and I show you the CSV file, you can see all the information's there, right? I could have also recombined all of these into one stream. Since it's a workflow, I can just copy it back to a standard label, and they'll all get combined. But I thought there must have been a better way to do this. So what I end up doing is moving on to what is going to be in demo 6. If I take a look, I'll restart it again, just for time constraints. And I'll show you what demo 6 looks like. So this is the configuration. You can see it's much shorter. It's much shorter because I'm using a new plugin that I called Netflow Normalizer. It's written in Ruby. It's a very simple thing. So you're using the lookup CSV, and then outputting all the stuff to a Netflow file. So if I show you the plugin, the Netflow Normalizer, there's a couple of methods, but really that's what I'm doing. I'm just doing a bunch of ifs and assigning the same variables, but instead of doing it by copying stuff over, which adds overhead and slows everything down, I'm just doing it in memory and code very quickly, very efficiently, and I can tailor that to whatever needs I need. So this is where I started writing, and you can look at the plugin for the lookup CSV. You'll see that it's fairly simple. I'm just looking at, there's a lot of debug code there still that I haven't cleaned up. And you're just looking up the value in a table right here. And you're outputting that information. And to show you that file, it's the protocol.csv. It's just simple CSV file, the number and the protocol name. So you could do that to pull out any type of lookups. I did it for this, but it's based on CSV. So I have this, and then I output the file. So if I send my demo 6 now, that it's running, you'll see I get the CSV and JSON, but I only get one file. Let's do the CSV one. You'll see you get 5 and 10. They're all in the same one. They're in the same format because I've normalized that data. So that starts to get interesting, right? Now, at least I have a bit less processing to do. But there's always ways to improve these things. So let's go to demo 7. So on demo 7, we're still building on top of what we did for demo 6. And what do we have here? We have a new plugin in there, which I call Match ACL. So one of the use case I needed to is once we've identified where everything was connected, we re-IP'd the network, moved stuff in what's called the CD and PCI terms and PCI network zone. We needed to write firewall rules for those. The problem is you're running a live network. It's hard to put it's easy to put rules in. It's hard to put rules out that could have adverse effect on the network. So what we ended up doing is writing a new plugin. What that plugin does is using another CSV format. If you see source, range, or IP address. I can do ranges as well. Protocol, ports, and I can assign either a number or a name to it. It'll match that traffic and assign that last value to it. So it also supports ICMP, supports a bunch of other little things in there. So if I think I need to restart. So the beauty of this tool is, I'll show you in a while, it matches things, and then I just add another field to the CSV file, which is the matching information. If I don't find anything, I put no match. So by just doing a grep no match, I can identify the traffic that's not being matched very, very easily. So if I do this again for demo 7, you see it's starting to get this stuff. If I do what's in there, you'll see there's no match traffic in there because these don't match. But there's some here that match the hostmon. Some of the rules I've set up. I had way more back in the day. The beauty of these things is you run this and you start adding new rules to your firewall sets, you identify these, and when you have very little no match stuff, you know you should be pretty good to go. This allowed us to remove the permit any rule in the firewall live. We did it around 10, 11 a.m. on a Tuesday morning, and the business didn't realize it. The only thing that broke was a VMware backup process. That's it. So just that, when you're in a challenging environment when everybody's tasked, it was a pretty awesome thing to get done. But I still figured out that there's ways to improve these. So this is great for dividing the ACL, for matching this. This could be used as a basis of a network IDS, right? Because ultimately, what is a network IDS? It's matching expected traffic versus your expectation of what traffic is. So you could do that and put all that unmatched traffic if you didn't want to put a firewall rule in there and get on-the-fly alerts, connecting it to Nagios or whichever alerting system you want. So this is cool. But I still have the information in CSV file, which is cumbersome. I have to transfer. If I'm sending it to somebody that's non-Excel savvy, that's not the best way to go, right? So what did I do? Well, there's got to be more ways to do this, right? Well, by looking at some of the plugins that are already available. So in demo 8, I'm not using the ACL portion, but I'm using everything else. I am actually using the ACL still portion. But I'm outputting not only to JSON and CSV, but to MySQL. So I have MySQL database running on this server, but it could be anywhere else. And if you take a look at the code, I'm basically using a prepared statement, so you might insert with the different parameters that I want, and I'm just outputting this to a file. So if I do, I'm going to have to go get the commands and the password, because it's a very complex password. I use the demo 8 database. I show tables. There's a table called Netflow. I have stuff in there, so let me just empty it. Okay. So there's nothing more now. I got to make sure. I got I don't know if I restarted it. Actually, I could just go towards the end. No, I don't think I restarted it. I'm going to use the same traffic, but what you're going to see is I'm sending this stuff, I do a tail, you're going to see stuff coming in. But if you look at this and I do a select, there's nothing. Oh, now stuff is starting to come in. So if I just do a count instead, just to give you the number, it's all in there. And if I scroll the window here, you'll see better. So I've got all the information. So if I do, so now you have information in a database, which means that you can farm that out to somebody that knows SQL and get some of that value and that information. So that's pretty good already, because by now it's easier to get the information. But I was tired. I mean, one of the issues we run into with networks is, oh, we were migrating, so they're putting in new servers in there. How do I know that there's a new server, there's a new IP address coming out? There's multiple ways to do it. And one way to do it that has its pros and cons, sometimes works, sometimes does not, is doing ping sweeps. So I could do ping sweeps and try to get that information in there. The other way is through Netflow itself. Netflow will report to me all the IP addresses it seems through the network. So if I keep a database of that, I can do something like that. So not name Demo9 for historical reasons. But you can see there's a bunch of tables that I've created here. I'll just go run through them. You have daily and regular. So I'm adding all the information to both a daily that has just as the date as another field. So you have all the flows that are regular and identified because I know it's a service running on a certain port that I've identified. I have the IPv4, so all the IP addresses that I find that I add to that catalog. So if there's a new IP address, it'll get actually port scanned. I have other daily flows, it's with in other flows, which is TCP UDP information for which I don't have a service port running. Now, this could be multiple things. Active Directory, for example, uses dynamic allocation of ports. So if you scan, you're not going to see anything. So that's all going to go in there. But that also means that is potentially something that may be used nefariously that you want to look at. I have a service, which is where I add the TCP UDP information. And then the unknown, I have the, the other flow is stuff that's not TCP UDP. That's the ICMP, BGP, all that stuff that I've thrown in there because there's no real port information there. And then I have unknown daily flow. Unknown daily flow is that TCP UDP I was telling you about that I've not been able to map. Sadly, for Demo9, I'll show you all the code, but I can't show you a running demo because that would require a live network. But the code will be out there, and that's the code works. So the way it works is I'm parsing this, I'm writing to a file if I find something, and there's a cron job, for example, that runs every 5 minutes that does port scans. So if I see a new host, it's going to get scanned within a few minutes. And I put that, and I manage that all through either cron jobs, and the cron jobs output and parse the nmap information, which I can actually show you. If I do the cron portion. Very simple cron jobs. So I run a ping sweep on periodically. So sources will just give you an idea of, I'm setting up /something networks that I'm port scanning and assigning it a name to it just for management purposes. But if I do the sweep script, it's very much just calling nmap, outputting everything, and just doing a cat of the gnmap files to a file that I will be reading again from fluentd, saying, okay, these are the IP addresses I found, adding those to MySQL. If it doesn't exist, if I don't have it in the list, I'll put it back to a file in logmon again that's going to be used by the port scanner. If I show you the port scanner, there's the nmap cron q, which is just the script for running the cron, and then there's a map script. This is running the queue. It's reading from logmon q nmap star, just reading a file. Once it's done, it's going to remove it. And I'm calling XSLT proc to transform that information from the XML format into a CSV format that I can figure back straight into the system. And for that one, I believe that's about it. I can switch back to PowerPoint. This is what we had. Okay. So this is what we have, right? This is what I've described this. And everything's still in MySQL. So now not only are you doing this, I mean, you could take it further, because then you can do proper analysis. It's easier to tag this to any other system and connect that. And while I've outputted to MySQL, there's nothing that says that you can't connect. If the company you work for or your client doesn't want to use MySQL, you want to use SQL Server, if you can get a plugin that works, you can output that. Or if it doesn't work, you can write your own. It's not that hard if you've got some basic experience programming. I don't even know Ruby, really, but I've managed to figure it out enough because I have a development background. So some little issues I ran into. So Netflow is UDP. So that means there's packet loss. As I was testing some of the demos over the weekend, I was experiencing some weird issue because guess what? I'm on a wireless network, and no crack hadn't come out just yet. So at least it wasn't known. It was just packet loss. So you can Google a lot of information. So the best thing is to have your collectors, at least from a network perspective, as close as possible to your data sources, which, because of the way fluentd is built, you can parse that locally and then try to collect that, centralize that through other types of plugins. What else we have? You have multiple devices that provide different information. So one of the things I was able to do that helped out some of the networking folks is in V9 information coming from the Cisco ASAs, it would actually tell you when a rule was hit, what ACL was hit by giving you a hash. So if you have the information and you're looking for example, to permit any rule, and you have the hash there, you can map straight to the hash directly and output that to other formats. So that's very possible, but there's more information in Netflow than in what I've discussed here. I've basically used 5 fields: source IP, destination IP, protocol, source port, destination port. But there's way more information, especially if you step outside of V5. Once you get to V9, V10, it can be extremely helpful. And obviously all of that information, they provide different templates, so I would look into that, what you can do. There's also the fact that multiple devices on the network, if they're all reporting, for example, I had VMware and the ASA and some Risco, some of the routers and switches, I could get multiple traffic information. That doesn't mean there's 10 times the traffic or 3 times the traffic. It just means that I'm getting reported more than once. So you can't use that for volumetry as much as you would like to. Couple of things with fluentd. You can set it up as a hierarchy and capture locally in UDP and then use TCP to communicate, which is going to provide reliability and ensure that you don't get packet loss. So that's one way to do it. Another use I've made of fluentd is for logging systems. So I basically had the NXLog Community Edition version installed on the Windows workstation, sending syslog information there. But that's just a standard syslog message that I used with a regex to convert into JSON and then filtered, and then through a series of workflow with a little GUI, we had a minimal logging and monitoring solution. That was enough to meet PCI. It's not rocket science, but we were trying to meet a PCI for a limited period of time. But you can also combine it with other search tools. So I spoke earlier about the ELK stack. So Elasticsearch and Kibana are very powerful. There are even other tools. The Etsy folk debuted, not this summer, the previous one at DEF CON, a tool they call 411, F-O-U-R-11. If you Google it, you're going to find it, which is basically an alerting mechanism on top of Kibana that they've used to replace, I believe, the ran Splunk. And so you can use something for logging and monitoring with such a solution, either Logstash or fluentd or something like that, and centralize, get all your logs, parse that, and then output those to different stations. What they did is they had like 3 different instances, one for security, one for compliance, one for the IT folks. So everybody can get their own sandbox of the data, but the data is flowing from the same individual source. So other things is this solution may require edits. I'm going to provide the code, and I'm going to try to be responsive as is, but it may require tweaks. And as you move forward, I've had to sadly use a printf method because it's a daemon running, and that's not fun, but it works. The other thing is, for those who are cognizant of Ruby, Ruby generally is packaged as gems. I did not do that. I didn't look into that. If somebody wants to do it, more the better. But all these files are in the plugin folder in /etc/tdagent/ /plugin. So everything's going to be published online. So if you guys have any questions, I'd be more than happy to take them now, or I'll be here the rest of the day as well.
Thank you so much. Questions? Questions? All right.
So how are you capturing the information from the Netflow protocol? Is it broadcasted, and can you just listen from any device?
Netflow is from your devices. It's a configuration issue. It's just as you would set up syslog, for example, there's different commands for different devices. So either through the web configuration engine or through the command line, you could just set it up. And that's where there's one parameter is the time between templates being sent. So this is all network device. I have a small router at home, and some of those provide that information as well. So and VMware has it in their console as one of the outputs as part of their network switch, their virtual network switch.
Did you run it? Is it working?
Yeah, just keep it closer.
Yeah. Did you run into any like CPU memory issues and like related to whatever's generating Netflow information, bugs, anything?
If I run into CPU issues?
Yeah, like whatever's generating Netflow information. For example, it's a switch, it's a router,
So my goal was not to check performance of the network. So performance of the tool, it's very memory. And memory and even CPU can get, depending on when you're doing port scans, that solution got a bit more. But memory, it's very, very lightweight. I actually want to try and run some of those on Raspberry Pis at home to do a proper analysis of my own traffic, what's going on there, even though it's only me, just because it's going to be interesting to see what else I can get. But CPU, it's very low. You're not going to, you could aggregate that information. You do get, in some formats, you can get the number of packets are sent. I think you maybe bytes or octets, depending on where you go. So that's why I'm telling you there's more information out there that I didn't process, because that was not my intent. My intent was to identify who's communicating to who so I can re-architect the network.
So just samples?
It was running real time. I was validating and continuously validating. But it's kind of applying the Pareto principle, the 80-20 rule, where you get 80% of the traffic, and then you focus on the other 20%, you get 80% of that, and then you're going to slowly get most of it, right?
Thanks.
You're welcome.
Thank you so much, Yves, for being here, and our out-of-town guest, which is also really awesome, because it's great when we have folks come from outside of Calgary. So thank you very much.
Thanks. I'll be around the remainder of the day if anybody's got other questions.